Briefly describe a model that is a visual image that you can put in your mind and that generally will help you understand at a mechanistic level how focus and concentration work. So what I want you to imagine is an arrow. And an arrow, of course, has an arrowhead and it has the shaft of that arrow. The neurochemical system that really represents the shaft of that arrow, right, the straight line, is epinephrine, also called adrenaline. The release of epinephrine overall increases energy. It increases alertness. It does not alone increase focus. Okay, so the reason I've assigned epinephrine, adrenaline, as the shaft of the arrow is that if focus is the arrow, there is no focus without epinephrine. Now, the arrowhead on this metaphorical arrowhead that represents focus and concentration is going to be represented or related to the mechanisms of acetylcholine, a different neurochemical. Acetylcholine is released from a couple of different locations in the brain, and the best way to think about it is it's like a spotlight. It highlights specific neurons, nerve cells that should be active, or more active, I should say, than the other neurons in the environment. So the reason I've assigned acetylcholine to the arrowhead is that if you have an arrow with a very big arrowhead that's really broad, really blunt, imagine a mile wide arrowhead, that's not very focused on any one location. It's not really pointing to any one location, is it? But with a narrow, really tightly focused arrowhead, well, that's focused on one location. So we have alertness, epinephrine, and then we have the actual direction in which our concentration and focus is placed, and that's acetylcholine. And then in order to have ongoing focus, we need another neurochemical. And it turns out that that third neurochemical is dopamine, a molecule often associated with pleasure and reward, but it's really the molecule of motivation.